In this video, I'm going to show you how to automate EVM Event Listeners without writing a single line of back-end code. By the end of this video, you'll understand what event listeners are, the different types, why they break, and then we're building a live USDC deposit alert together. Now, why does this matter? In 2022, the Ronin Bridge hack drained $625 million, and the team only found out 6 days later when a user complained they couldn't withdraw. You know why? They had no event monitoring, nothing watching their own bridge contract for large outflows. That's what happens when the system that's supposed to watch your smart contracts doesn't exist, or breaks and nobody notices. So today, I want to show you a way to make sure that never happens to you. And the whole setup? It takes about 5 minutes. Let's get into it. Alright, so the basics. When a smart contract does something, transfers a token, registers a user, it can emit an event. That's the contract saying, hey, this just happened. A log entry, cheap, indexed, easy to query. A listener sounds simple. Tell a node to watch a contract, and when it emits an event, let you know. In your local environment, that's exactly how it works. But under the hood, your listener is tracking block numbers, managing confirmations, handling reconnections, coordinating side effects, none of which the EVM does for you. What feels like a 20-line script is actually a small distributed system pretending to be simple. Not all listeners are the same. Block listeners watch for new blocks. They power explorers and analytics. Contract event listeners subscribe to specific events like transfer or approval, your token trackers and notification systems. Transaction listeners monitor the mempool. This is where trading bots and MEV searchers live. And price listeners watch Oracle feeds from Chainlink or Pyth, powering liquidation engines and stop-loss bots. Different types, same core problem. Staying reliably in sync with a chain that's constantly reorganizing itself. Now picture your event listener as a security camera. In staging, it's watching a quiet street. 5 cars an hour, catches everything. Ship it to production, and now it's on a 6-lane highway during rush hour. The road shifts under you. Chain reorg. The camera blinks, WebSocket drops, and when it comes back, it has no idea what it missed. That's production. A reorg reverses an event your database already processed. A WebSocket dies silently and your listener skips a block. A retry misfires and triggers the same payout twice. To handle this properly, you need confirmation tracking, duplicate protection, replay safety, persistent cursors. Your 50-line script just became a full orchestration system, and most teams don't have the bandwidth to build and babysit that. Which brings us to the part I actually want to show you. So instead of just talking about this, let me show you what it looks like when you throw away all that glue code and replace it with a workflow. We're building a USDC deposit alert from scratch right now. Here's what we're building. A USDC treasury notifier. Whenever someone deposits USDC into our treasury contract, Kwala fires an instant alert to Discord. No backend or polling. Deposit happens and Discord pings. This same pattern works for token sales, crowdfunding, revenue sharing, cross-chain calls. But let's start simple. I've got the treasury contract deployed on base Sepolia with a mock ERC20 named USDC. When the deposit function runs, it emits an event called USDC accepted. That's our trigger. Discord notifications channel is ready on the other side. That's our action. In Kwala, I'll create a new workflow, USDC received notifier. Execute immediately, and I want it to repeat on every event. For the trigger, smart contract event. I'll paste the contract address, select base Sepolia. Since this is freshly deployed without published source, the ABI section is blank. No problem. I'll paste the contract code manually, and Kwala workflow extracts the ABI automatically. Next, adding the event name, USDC accepted. Data types only, no spaces. For expiring details, I want the smart contract to expire in the next 2 hours, and this is going to be a post URL call. The action here will be the Discord notification, so adding the name as Discord call, then Discord API details, API endpoint, and the text for my Discord message is USDC received on USDC Treasury Vault smart contract. Review, compile the YAML, save, deploy, activate. It takes a few seconds. Now, let's test it. One setup step. The Treasury only accepts approved wallets. So I'll compile this code and we are going to call this particular smart contract and deploy. I already have my base testnet set up. Now I'll call the Mint ARC20 smart contract. Here, the spender will be the Treasury contract. Once I add the details, user 1 should be accepted as the sender since it has enough USDC. I'm approving a spending cap of 2 USDC first. Once the transaction is complete, I'll move to the Treasury contract. Since user 1 is already approved, I can now deposit 1 USDC into the smart contract. Before confirming, I'll quickly check if the Kwala workflow is active. Yes, it is, so I should receive a notification after the transaction. Transaction confirmed. Block Explorer shows it about 15 seconds ago. And boom, there's the notification, right there in Discord. Triggered automatically the moment that deposit event fired on chain. No listener script, retry logic, or backend. Just a Kwala workflow doing exactly what it's supposed to do. Now I'm curious, what would you automate with Kwala? A token tracker? A payment confirmation system? A cross-chain trigger? Drop it in the comments. I want to see what you'd build. And if you've already dealt with a listener breaking in production, tell me that story too. I know some of you have war stories. Check out Kwala at kwala.network, links in the description. Hit subscribe if you want more of the EVM world. I'll see you in the next one. Keep building.